In section 7.3, now we're looking at creating confidence intervals for means when the sample standard deviation is unknown. We could have the situation where we are given the sample statistics, like the sample mean and the sample standard deviation and the sample size, and we use those immediately to calculate the error bound that we can then use to create our confidence intervals. But often, if we're collecting our own data, we have to find all of those statistics and then use them. And so that's what the next two examples do. We have actual data we're working with. We have to calculate the sample mean and the sample standard deviation first, and then we can go into technology. We can go to the formulas that are built in to calculate our confidence interval. So we're doing a study of acupuncture to determine how effective it is in relieving pain. We're measuring sensory rates for 15 subjects with the results given here. Use the sample data to construct a 95% confidence interval for the mean sensory rate for the population from which you took the data. I'm going to come back up there and highlight 15. And yeah, the solution is shown by using the calculators. We're not using calculators. We're going to use Excel or Google. So, let's write down what we know. We know n is 15. We have a 95% confidence level, which means alpha is 0.05, which would mean, if we're using the normal distribution, that we already know what z is, but we're not using the normal in this section. If we don't know the population standard deviation, we have to use the student t-distribution. Sigma is unknown. We need to use the t-distribution. Take a moment, pause the video, and input your data into Excel or Google. And I'm going to do a really quick check that you can do to make sure that you entered it correctly. And that is calculate the sum. The sum that you want to find when you enter in all this data, add them up. If they equal 123.4, then it's likely you did not make a mistake. There's still a small chance you could make 2 mistakes or more. One corrects the other one, and that's going to throw off our calculations a little. But one way that we can check if we're transcribing our data from a book like this into Excel, and we're not allowed to copy it, we have to type it in. One way that we can do this is if we have a check, and I'm giving you that check. Sometimes it won't be given. Sometimes my open math gives you a checksum. That's what they are doing. They're taking the data, adding them all up, and giving you a way to check, not guarantee that you entered it correctly, but to feel more confident that you did. So pause the video, enter in the data, use your sum formula, add them all up, and see if you can get 123.4. If you can, then the next step is to calculate the mean and the standard deviation, and then use the confidence.t formula and calculate our error bound for the mean. I'm going to start out with my data pretty small, just so that you can see that I have all 15 numbers entered and that my checksum at the bottom, 123.4, is equivalent to our checksum that I gave you. Making things a little bit bigger just so that you can see them easier. We're going to start out by finding the average. And I know my data is in the cells A1 through A15, so I'm going to type it in simply for space, but know that you can also use your mouse. And our average is 8.2267. Our standard deviation for the sample is 1.6722. And we also know that n is 15. We are given a 95% confidence level so that we know that alpha is 0.05. I'm just going to throw that in there too. And to calculate our confidence interval, first we have to calculate the error bound. And I'm going to do it off to the side here. So to calculate our error bound, confidence.t, we're going to put in alpha first, then our standard deviation, and then our size. Since I already have them calculated here, I'm just going to do cell references so I don't have to type them in. Confidence.t, alpha, standard deviation, and our size. Alpha, standard deviation, and our size. And we put them in at 0.05, our standard deviation 1.6722, and n is 15. Google calculated back for us 0.9260, ... but 4 decimal places is likely okay. And once we have our error bound, then we can find the limits for our confidence interval. Mean minus our error bound, mean plus our error bound, and our mean we calculated, and I'll write that down really fast so that we have it, 8.2267. 8.2267 minus 0.9260 and 8.2267 plus 0.9260. These two numbers together will create our confidence interval. But again, we can get Excel to do this for us, or Google. Know that when I say Excel or I say Google, I really mean both of them. Labeling some information so that we know what we have. Lower bound, upper bound. Our lower bound is going to be the mean minus the confidence level, the error bound. And our upper bound is the mean plus our error. 7.3009153. My raw data has 1 decimal place, so I want to round my confidence level. I want to round my confidence interval to 2 decimal places, 1 more place than the data. And that's what we mean by using standard rounding rules. And we have our 95% confidence interval. But with all that said, we're not done. That's not quite enough to finish out the problem. We should interpret it. What does it mean? We can say we are 95% confident. The true population mean sensory rate is between 7.30 and 9.15. They don't give us a unit here so that we can't put units in our interpretation, but that's okay. They're giving us a rate. We're 95% confident that our population mean is between 7.3 and 9.15. Be mindful of the rounding in My Open Math. Make sure you're rounding to their specifications. I am pretty flexible with this, knowing that there is a difference between them. But when in doubt, more decimal places are usually better.